Session is going to present on the exports implementation plan. If anybody wants to leave their poster up there in the corner, Mary said she'd take it up and hang it for you. So just leave it in the corner as you go to lunch, up there in that corner near that exit sign, kind of off to the side. Thank you.
Thanks, Heather. Can you guys hear me? Yep? Okay, great. So we had a great series of talks before the break. Mary Jane and Adrian and Scott did a really great job of orienting us to the science and giving us an overview of both the state-of-the-art capabilities that the scientific community has now, as well as a lot of the uncertainties in twilight zone processes and some of the prognostic models that we use to predict the fate of NPP in the ocean. So those talks together left me with the impression that really, one thing we really need is more observations, and especially concerted observations of all the different parts of the biological pump together. And so that's that need that exports, we hope, will be able to fill. So I'm going to be presenting the draft implementation plan for the exports program. I have a whole bunch of people that have been helping put this together, so I'm just sort of speaking on behalf of them for this talk. I'm going to start off by just, you guys have these little handy-dandy cards in your folders. I'm going to explain the safety features of the auditorium now. No, I'm not. I'm going to explain, tell you to refer back to here. I'm going to be speaking a lot about the exports wiring diagram and the different export pathways and the 3 science questions, which are here for your reference. And there's more stuff for the NSF biology of the biological pump, some reference figures on the back for this afternoon, but export stuff. Okay. So also going forward in the talk, I'll be referring to something that I might call an ECC state or an ecosystem and carbon cycling state. So when we refer to that, we're just thinking about some configuration of the different pathways that are in the exports wiring diagram model. That is not right. I'll just use the easy one. Wiring diagram model here. I stole this slide out of Rue's talk. Like literally grabbed it out of his talk, but we can see here 2 hypothetical ecosystem and carbon cycling states where we've got different export pathways that are operating at in different ways in different places in the ocean at different times. Okay, so in this talk, I'm going to spend a little bit of time talking about how the science definition team for the exports program came up with this draft implementation plan. So I'll just talk about process briefly. And then I'm going to go over the broad, sort of important details of the implementation plan. The implementation plan is it's much more full of detail than I can possibly get through in half an hour. So I do urge you to go online and check it out. There's a link at the bottom of your seat back card here that's got, if you follow that link and then click on the blue draft implementation plan link, you'll get to all the documents that show all the figures and tables and everything that I'm going to be going through here. So I will also then, after I go over the details of the plan, spend some time talking about the cost estimate that we came up for this plan, and then finally some alternatives, depending on what the different agency budget scenarios are. Okay, so I'm also going to be referring a lot to something I'm going to call the goal plan, which is basically the science definitions team's best implementation of field observations and modeling work that will answer all the science questions 1, 2, and 3, with a high degree of certainty. So we feel like there's not a lot of risk with the goal plan that we won't achieve our aims. So that's what the goal plan is. And then because the types of proposals that might be received, so every role in this will be competed, so people's ideas might be different, but what gets proposed might be different, budget scenarios might change. So I'm also going to talk about some of the different implementation options that we have thought about. So as I go forward, I invite you to think about, I've got some leader questions here that I've put up. How might the goal plan be improved to better answer the science questions? In choosing between the options, which science is the most important, which risks are easiest to accept? Could the suggested management structure be more effective? Should the timeline or geography change? All of these things, as well as any enthusiastic comments, support, we should definitely do this. All this stuff, we'll be asking for you guys to share your feedback during the discussion period following the talk. So you can do it that way right here in the room. If you're watching the web stream, you can email to ocb_live@hui.edu. We'll have some early career discussion tables set up, I think numbers 1 through 6 at lunch today, and then there's an email address at the bottom there to formally put your feedback in and connect with NASA on this program's implementation by September 1st. So the first thing I want to go through is how do we actually come up with this implementation for this field and modeling plan that answers these science questions. We started with the science questions, and we basically went through and made we did a big brainstorming operation. So we thought about what are all the state-of-the-art observations and models that we're going to need in order to answer each of the science questions and sub-questions that you've heard about so far in the talks before the break. Then we prioritized those measurements and thought about the logistics of putting them on ships together, getting them on the autonomous vehicles together, and implementing all of that. And then came up with a field plan that then we could cost and come up with a cost estimate for. So you don't need to read all this text here. These are the 12 science questions and sub-questions that are in the peer-reviewed finalized export science plan. As an example, I'm just going to walk through this brainstorming exercise that we used in science question 1C. So what controls particle aggregation and disaggregation of exported organic matter, and how are these controls influenced by plankton community composition? So if we're interested in how plankton community composition affects aggregation and disaggregation, we need to know something about plankton community composition. So we've got a bunch of measurements that actually achieve that we would want to implement in the field in order to characterize that part of the ecosystem. We need to know something about the zooplankton processes that might be affecting fragmentation or repackaging of organic matter. We need to know about the aggregates themselves. How big are they? Where are they located? What's their sinking flux? We need to know about the composition of the materials that make up those aggregates. There's a lot of bulk geochemical measurements that would go into this. We need to know about the physical processes that are going to cause aggregates to move around and form and disaggregate. And then finally, we need to have those optical measurements that are both going to serve as proxies for particle composition and type, but also allow us to link back to remote sensing and those satellite-based models that we're sort of moving towards in the long term. So that's a big, long list of measurements. This is just for one of the sub-questions of exports. And in order to make some sense of that and to really start to think about the logistics, how many people, what ships, what profiling or sampling modes do we need to use, we sorted them into what are called the exports program elements. So here we're looking at measurements that together enable us to characterize the phyto and microplankton, the zooplankton, export, bulk geochemistry, and physics and optics. You'll see these again. But these are how we're grouping PI groups. It's how we're grouping work that's going into C for these things. Okay. So next, I'm just going to go over, like I've covered the brainstorming and formulation process we went through. I'm going to go over now the major details of the implementation plan and orient you to some of the documents that are online that you can look at in more detail. So this is a giant spreadsheet. You are not meant to read all the words, clearly. I shrunk it so it would fit on one slide. But this is a big table. It's the exports measurement table. It has about 80 entries, I think, something like that. And together, it's all of the measurements that the science definition team thought up as being necessary or useful to answer all of those science questions from questions 1 and 2, the ones that really need some field observations. These 3 columns that I've highlighted here give the purpose of the measurement, the examples of the measurement, and how it relates to each science question. So that's explaining what kind of measurement we need. And then these 2 columns here map every single one of those 80 measurements back to at least one, often more, of those science sub-questions. So there's a direct link in the measurement table that you can use to see how different types of observations are traceable back to the science that's motivating them. And then we've sorted them. All those sub-questions are now grouped together by program elements. So when we're trying to implement this in the field, we thought about what kind of personnel and effort are necessary to carry out all of these different measurements within each of the program elements that you see here. So many of the observations in the table are direct measurements you'd want to be doing on board a ship. but some of them actually can also be either carried out directly or via proxy on autonomous platforms like floats and gliders. So as I think Mary Jane has already alluded to in her talk, one of the things that makes, and Rue as well, one of the things that makes exports innovative and new is that we're going to be able to utilize networks of autonomous platforms to extend the observations that we make on the ships along an annual timescale and over and get some spatial context and persistence with those measurements. So this is an incomplete list of some of the proxies that we can now access from sensors on autonomous platforms. It's not complete. There's certainly more things in development. And by the time this goes in the water, with luck, we'll have even more options. So what do we gain by employing an array of autonomous platforms alongside our ship-based measurements? We get persistence. So we get to see the full annual cycle that goes around our ship-based cruises. We get the spatial and temporal context for the cruise. And we have confidence that the data that we use ultimately to answer science question 3 are representative, right? So that we know where our ship-based observations sit in the broader scales. There's way more detail on the autonomous implementation plan in the draft plan, section 4.3. So if you're interested in the details of that, I invite you to look there. Also, as Rue has introduced, we're going to be we're proposing that the exports observations be carried out aboard 2 ships. One of them we're going to call the process ship. It's a water following ship, water parcel following ship. So the idea is that if you have measurements that need to look, if you're looking at rates or things that you want to be watching evolve in a single water parcel, that would belong on the Lagrangian ship, things like sediment traps, net tows to get at zooplankton process measurement, things like that would go on the process ship, and the survey ship would operate at the same time, but conducting surveys of more broadly distributed parameters around the process ship. In addition to those 2 ships that would be going out in each of